My name is Tian, and planning and operational aspects of microgrids embedded with renewable resources and distributed energy resources is what I want to talk to you about today. This presentation has 5 parts, which are introduction, literature review, research design, conclusion, and reference. Next, I'm going to talk about the introduction. Initially, what's the microgrid? A microgrid is defined as a localized group including electricity sources, load energy storage devices, monitoring devices, and protective devices. This microgrid usually not only can be operated connected and synchronous with the traditional advantage grid, but also can be disconnected to independent mode in order to meet physical and economic conditions. As we know, environmental issues have gradually become the focus of research because of increasing amounts of carbon gas emission in the atmosphere leads to climate change. So renewable energy technologies have developed rapidly. The microgrid is widely regarded as a solution for environment caused by the greenhouse gas emission, and it also contributes to solve the energy shortage problem, which means some energy sources will not be reused, such as coal resources, natural gas, and other non-renewable resources. So the renewable resources are the necessary part of microgrids. The limitation of microgrids could be found that due to the unpredictability of the funds, such as solar energy and wind energy, which are the main supply for the microgrid. The power supply capacity of microgrid is stable. Based on the problem mentioned above, a method depending on probability distribution functions was demonstrated, aiming at a practical solution of forecasting renewable resources, and then predicting whether the output power converted from the resources. These resources can meet the electricity demands in an area. So the research topic and the question is important. Next, I'm going to talk about the literature review. The literature review would discuss the recent development of microgrids and the forecasting applications in microgrids and several methods of forecasting renewable resources from widely perspective to more particular aspects. The issue of climate change has triggered rapid technological advances in the renewable energy industry. Over the past decade, such as technologies have switched to clean and sustainable sources. So distributed generation from renewable resources will be the optimized choices. It is because the disposal of IE resources, the different methods of power generation should be chosen to maximize its benefits. Many international researchers and experiments on microgrids are conducted in the world, such as European Union, Japan, Korea, North America, and many other countries. Next is forecasting applications in microgrids. Forecasting applications and energy management system are inseparable because EMS is provided various data for each generation unit and loads in microgrids, such as operation commands, parameters, and operation model. Furthermore, this system can also provide predicted information, including wind speed, solar irradiance, and other prediction parameters. To obtain relatively accurate future parameters, it is necessary that forecasting system has a function of convergence probability. Next, I'm going to talk about several methods of forecasting renewable resources. Based on the operation of wind and solar energy, the design includes several stages. The first stage is explaining an optimal plan for 1 day ahead energy transmission. And the second step is simulating the operation of wind and solar energy. Finally, they also use the same data of the solar and wind power output to simulate energy scheduling results from pointing forecast and scenario method. The second method is based on historical data. After studying the properties of PV output, the author proposed a 1 day ahead power prediction method, which is dependent on the historical generation data and weather condition to forecast the 1 day ahead power based on the different historical date times. The second design is based on the relay probability density function. Due to the wind and the solar have a random feature, the output power from these energies is uncertain. So the author provided two probability density function to simulate the condition. After calculating the wind speed and solar irradiance, the output power from the wind turbines and PV units can be calculated respectively. The next step is to simulate the generation scenarios of the two types of renewable resources. Finally, applying effective scenarios to predict 24 hours energy output. Next, I'm going to talk about my design. The first step of the new model is that selecting a location where has microgrids, and they can be supplied by renewable resources, which mainly includes wind and solar energy. Secondly, collecting the total electricity consumption in the region within 3 months is indicated by PT. The number of the days is indicated by DT. And then total electricity consumption divided by the total number of the days in 3 months. Therefore, the daily electricity consumption in this area can be calculated. Then selecting the data from 3 months, because the climate in many countries will change within 3 months. So the electricity consumption will change as the climate. To ensure the accuracy of the data, the information above can be achieved by the authorities, such as local power supply bureau. Thirdly, through the forecast weather, network information to calculate the wind speed and solar irradiance. Then the method of the relay probability density function can be used to obtain the value of output power inverted from the wind and solar energy within 24 hours. Many samples are the key to ensure the accuracy of the data. The next step is comparing the value PD and PI. If PI is greater than PD, this indicates that the forecasting power supported by renewable resources can meet the electricity demands in this area. Otherwise, it means the microgrid system cannot supply enough electricity to the region. In this case, other measures should be taken to ensure conditioners power supplies, such as combining to the grid. The result shows that relations between predicted power and electricity consumption from mathematical perspective. And that is the reason the design was selected. It provides a plan for the power system to deploy the microgrid in advance. For example, whether to use storage power. However, due to the small sample size and location limitation, this design cannot be applied to every place. Another limitation is that this design focuses on wind and solar energy rather than all the renewable resources. In conclusion, it is necessary to forecast renewable resources because it can improve the service of microgrids. Further solution dedicated to improving the accuracy of predictions and reducing the amount of consumption. That's the references. That's all my presentation. Thank you.